After the final position is reached, the holding key is removed and its forked end is put on the hexagon of the transfer part. To release the transfer part from the implant, the arrow on the ratchet must now be set to counterclockwise. The screw connection is released and the transfer part is removed. The final vertical position is reached when the implant shoulder is situated at the same height as the enamel cementum margin of the adjacent teeth. The implant should be surrounded by a layer of bone at least 1 millimeter in thickness. The small marginal recession is later augmented with autologous bone chips. In aesthetically important areas, the implant shoulder can also be placed 1 millimeter deeper than the enamel cementum border of the contralateral tooth. This position allows an optimal emergence profile of the future restoration. The inside of the implant is now coated with nebacetin ointment. For partially submerged healing, a beveled healing cap is screwed into the implant by hand using an SCS screwdriver. The marginal bone defect on the vestibular side is now augmented with autologous bone chips. Small chips can be taken directly from the immediate surroundings of the basal alveolar process with a sharp periosteal elevator. A membrane can be omitted, but the mucoperiosteal flap is relieved basally by a slit in the periosteum. This ensures tension-free wound approximation. The wound edges are approximated interdentally with atraumatic monofilament sutures. This is followed by closure of the vertical relieving incisions. The sutures are removed after about 7 days. The post-operative X-ray shows the correctly placed Straumann Standard Plus implant with the implant axis in good parallel alignment with the adjacent teeth. The Synocta cemented abutments for cement-retained crowns and bridges adds to the range of indications for the Synocta prosthetic system. The determining advantage is that the abutment can be shortened on the model by the dental technician instead of in the mouth by the doctor. This allows the superstructure to be optimized for the clinical situation. Osseointegration of the 3 Straumann implants in this 32-year-old patient was uncomplicated. This is demonstrated by auscultation and by the soft tissues which are free of irritation. The Straumann implant wide neck at tooth 4-5 and the 2 Straumann standard implants regular neck for the congenitally absent 1-5 and 2-5 had been inserted 8 weeks previously. For impression taking, the SCS healing caps are removed and the internal threadings of the implants are thoroughly cleaned and dried. Then the impression caps are placed on the respective implant shoulders and snapped firmly into place. The rotation test shows that the impression caps are securely positioned. Next, the positioning cylinder is aligned inside the impression coping and inserted as far as it will go. There should be no gaps between the impression coping and the positioning cylinder. The same procedure is used for the wide neck implant. The impression is taken using a custom impression tray and an elastomeric impression material. This is the finished impression of the upper and lower jaws. The implants are now once again closed using the SCS healing caps. The corresponding analogues are selected in the dental laboratory. When repositioning the analogues, care must be taken to ensure that their shoulders snap firmly into place. A gingival mask should always be used to achieve an optimal cervical crown contour. The working model is created, as usual, using dental stone. These are the completed working models with the 3 implant analogues and the gingival mask. After checking the clinical situation on an articulator, abutments can now be selected. For this purpose, a special prosthetic planning kit is available to dental technicians to facilitate the choice of the correct components and to keep inventory levels at a minimum. This planning kit includes plastic try-in abutments for crowns and bridges that can be placed on the implant analogues to verify their heights and axial inclinations. First, the dental technician hand tightens the Synocta cemented abutments in place on the analogues using the SCS screwdriver. Care must be taken to ensure that the abutment is placed within the octagon of the analogue. Now the clinical situation is reviewed on the articulator and, if necessary, as in this case, the occlusal distance is corrected by reducing the length of the abutments. The dental technician can subsequently use prefabricated parts for creating the superstructure. In this case, castable Synocta burnout plastic copings for crowns were placed on the shortened abutments by pressing until the caps clicked into place. These caps are cut in height as required. Once this is done, the crown framework is waxed up as usual according to standard veneering techniques. Once completed, the superstructure model is invested. After the initial casting, the snap-on mechanism must be removed with the reamer before placing the casting on the analogues. After core firing, the casting is veneered following anatomical guidelines. This is followed by main firing, correction firing, and glaze firing. These are the finished porcelain fused to metal crowns. They can be seated on the analogues without the slightest tension. To ensure correct transfer of the positions of the synoctor cemented abutment from the working cast to the patient in the dental office, a transfer aid can be used. It's made of plastic, can be attached by polymerization, and can be slid onto the synoctor cemented abutment. A resin index is created on the working cast in order to transfer the abutments to the patient. The structure is handed over to the dentist with the custom-reduced synoctor cemented abutments on the working model. In the dental office, the healing caps are removed, and the interiors of the implants are thoroughly cleaned and dried. Then the synoctor cemented abutments are placed inside the internal octagons of the implants using the transfer index that was created. Using the SCS screwdriver and the ratchet with torque control device, the base screws are tightened in the abutments. The torque should be 35 Newton centimeters. Now the restoration is ready for trial insertion in order to check for proper occlusion and articulation. If necessary, any occlusal corrections are made, followed by final polishing. A glass ionomer cement or zinc phosphate cement is used for final cementing. The synoctor cemented abutment for cement-retained restorations allows custom shortening by approximately 1 to a maximum of 2 mm, which can be done directly on the model, and the safe transfer of the abutment from the model to the implant. The missing single tooth 1-1 is to be restored with a transversally screw-retained porcelain crown. There's sufficient interocclusal space, and soft tissue management and the gingival emergence profile are favourable following uncomplicated osseointegration of the Straumann implant. For impression taking, the SCS healing cap is removed and the internal threading of the implant is thoroughly cleaned and dried. Then the impression cap is placed on the implant shoulder and snapped firmly into place. The rotation test shows that the impression cap is securely positioned. Next, the positioning cylinder is aligned inside the impression coping and inserted as far as it will go. There should be no gaps between the impression coping and the positioning cylinder. The impression is taken using a custom impression tray and an elastomeric impression material. This is the completed impression with the impression coping and positioning cylinder in place. The implant is now once again closed using the SCS healing cap, and the temporary restoration is inserted. At the dental laboratory, the corresponding implant analog is repositioned in the impression. The shoulder must snap firmly in place. A gingival mask should always be used to achieve an optimal cervical crown contour. The working model is created as usual using dental stone. This is the completed working model with the implant analog and the gingival mask. After checking the clinical situation on an articulator, the abutment can now be selected. For this purpose, A special prosthetic planning kit is available to dental technicians to facilitate the choice of the correct components and to keep inventory levels at a minimum. This planning kit includes plastic try-in abutments for crowns and bridges that can be placed on the implant analogues to verify their heights and axial inclinations. The RN Synocta transversal abutment is placed on the RN Synocta analogue and aligned inside the octagon. The screw is manually tightened using the SCS screwdriver. A total of 16 different positions are available for the transversal opening. After positioning, the RN Synocta TS plastic coping is placed on the abutment and a transversal screw is used with a hexagonal TS screwdriver to loosely attach it. The interocclusal relations are checked and the crown framework is waxed up according to standard porcelain fused to metal procedures. The application of graphite to the threading of the thread protection screw and of the cap is important. This ensures that the thread protection screw is easily removed after casting. Next, the modelled crown is invested. This is the completed cast crown framework. The construction can be placed on the working cast without any tension at all. The interocclusal space is sufficient as well. The casting is veneered with ceramic material following anatomical guidelines. The completed crown is first retained on the working cast with the transversal screw, and the occlusion and articulation are checked. To ensure a correct transfer of the position of the RN Synocta transversal abutment from the working cast to the patient in the dental office, a prefabricated transfer aid can be used. It's made of plastic, can be attached by polymerization, and is simply slid onto the RN Synocta transversal abutment. A transfer index is created on the working cast in order to transfer the abutment to its precise position on the implant in the mouth. The healing cap is removed from the implant at chair side, and the interior of the implant is thoroughly cleaned. Using the transfer index, The RN synocta transversal abutment is precisely replaced on the implant and manually tightened using the SCS screwdriver. The base screw is definitely tightened to a torque of 35 Newton centimeters. Once this is done, the crown fits easily and exactly on the abutment and can be manually screwed in place palatally in a transverse direction using the TS hexagonal screwdriver. The follow-up radiograph shows that the implant is positioned according to the intended long axis and that the crown is placed on the implant shoulder with no marginal gap whatsoever. Transversal screw retention can be used wherever an occlusal or incisal screw cannot be used for aesthetic, design or functional purposes.